Welcome to Quantum X. The main character of this video once spent nearly 2 years in a well-built home located in a good neighborhood with a stable lifestyle. Structurally, it was complete, solid frame, full utilities. But for him, something essential was missing, a true connection to the environment. That's when he made a difficult decision. He sold the house and moved on to a large, remote farm. Out here, everything starts from zero. No infrastructure, no ready utilities, just land, time, and accumulated experience. This project is more than just a timber frame cabin. It's a study in load-bearing structure, material selection for rural climates, and efficient off-grid construction methods. In this video, you'll witness the full process, from foundation work, structural framing, to final detailing. If you're into real-world building, DIY, or off-grid living, this is a journey worth following. Stay until the end, because the most critical decisions are always made in the later stages.
On his first day at the farm, he doesn't start with the house. He starts with water. In off-grid construction, water is always the first system to solve. Without it, everything else, concrete mixing, timber treatment, even basic living, comes to a halt. The existing water storage is heavily degraded: rotten wood, contaminated surfaces, poor retention. Instead of tearing it down bilkamil, he opts for a temporary repair, saving time and using available materials. He builds a simple wooden structure. No blueprint, no strict standards. But there is clear logic. A basic load-bearing frame, evenly distributed supports, and proper slope for water flow. It looks freestyle, but it's not random. It's practical experience, knowing what must be precise and what only needs to work. Once completed, the water source becomes noticeably cleaner and more stable. Not suitable for long-term domestic use, but sufficient for construction needs. This structure will eventually be removed, but technically it's a correct first step. A temporary system supporting a long-term build.
After stabilizing the temporary water source, he moves to a more critical step: foundation preparation. The first task isn't digging, it's clearing the ground. All the grass and organic layers are removed to expose the natural soil. It may look minor, but organic soil is never suitable for long-term load-bearing. Next comes the layout. He uses wooden stakes and red spray paint to mark the exact foundation positions. Once the layout is complete, he hires workers to dig the foundation holes. That's a smart decision. Excavation is physically demanding, but doesn't require the same level of precision as the structural stages that come next. This stage may look simple on camera, but in reality, the foundation determines the life of the entire house. With the foundation holes completed, he moves to the next step, laying crushed stone at the base. Conditions are not ideal. Continuous rain has weakened the soil, preventing large trucks from accessing the site, a common issue in rural builds. He adapts quickly. Using a smaller vehicle, he transports the stone in multiple trips. Slower, but it preserves the integrity of the already soft ground. The crushed stone is evenly spread across the base of each hole. This layer acts as a technical buffer, improving drainage, reducing concentrated pressure, and limiting uneven settlement. Once the stone is in place, he uses a mechanical compactor to compress the layer. This step is critical. Without compaction, the stone remains loose and unstable under load. Proper compaction binds the layer together, creating a solid base for the structure above. For a timber frame house, where loads are transferred through specific points, this compacted base directly impacts long-term stability. A technically sound step, executed under less than ideal conditions. With the compacted stone base in place, he moves into the foundation stage.
Steel rods are driven into the ground at key reference points, marked with red paint for clear visibility. From these points, the entire structure will rise. Any error here carries through the whole build. Next, he dry places the concrete blocks at the foundation corners. This test fit step allows him to verify spacing, elevation, and squareness between load-bearing points before permanent installation. Instead of pouring a fully solid traditional foundation, he chooses a lighter solution, using precast air-rated concrete blocks to form a strip foundation for the timber structure. It's a practical choice. For a lightweight building, this type of foundation allows faster construction, lower cost, and still distributes loads evenly into the ground. Concrete spacers are carefully positioned beneath the reinforcement steel. Their role is not just support, they ensure proper concrete cover. Without it, the steel would be exposed to moisture and corrosion over time. Another key detail is the drainage layer.
He installs a dimpled foundation membrane with the dimples facing downward toward the soil. This orientation creates void channels, allowing groundwater to flow away instead of building pressure under the foundation. In wet soil conditions, this becomes critical. It reduces hydrostatic pressure, limits moisture intrusion, and keeps the foundation system more stable over time. A simple foundation system, executed with correct engineering principles.
With the foundation blocks accurately positioned, he moves into structural reinforcement. The aerated concrete blocks are designed with built-in grooves. These channels allow reinforcement steel to be placed directly inside, turning separate blocks into a continuous foundation system. This is a critical detail. Even for a lightweight structure, tying the blocks together with steel and mortar ensures better load distribution and reduces the risk of cracking or uneven settlement. He places the steel bars along the foundation lines, maintaining consistent spacing between them. Nothing overly complex, but structurally sufficient for this type of build. Next comes the mixing process. He sources water from an existing well and uses a generator to power a handheld mixer. In off-grid conditions, this is a standard approach. What matters most is controlling the mix ratio, because in foundations, mortar quality directly affects structural integrity. The specialized mortar is poured into the base, encapsulating the steel and bonding the blocks together. At this point, the foundation system begins to take shape, built from simple but essential steps.
With the core foundation in place, he moves into spatial definition, marking the wall positions. On top of the completed foundation, every line is re-measured, not just to locate walls, but to verify squareness and catch any accumulated errors from earlier stages. At this point, precision is critical. In timber frame construction, any misalignment at the base will make the entire structure difficult to assemble accurately. He installs a waterproof membrane directly on top of the foundation at the junction between the foundation and the wall. This acts as a damp-proof course, blocking moisture from rising up through capillary action. In many builds, this step is overlooked. The result is walls that absorb moisture, leading to mold and long-term internal deterioration. This membrane doesn't carry structural load, but it protects the entire wall system above from continuous moisture exposure. Especially in wet soil conditions like this, water will always find a way upward unless it's stopped at the base. He begins laying bricks to form the base and floor level. This layer acts as a transition, raising the floor height while creating a flat, stable surface for the framing system above. But the weather becomes a factor. Continuous rain interrupts progress, stretching this phase to nearly 2 weeks. In wet conditions, brickwork requires careful control of moisture and curing time. Rushing this step would weaken the bond and compromise long-term stability. He doesn't force the schedule. Instead, he maintains a steady pace, ensuring each layer is properly set. A seemingly simple base, but one that defines the accuracy of everything built above it.
He applies a layer of bitumen coating across the entire outer surface of the foundation wall. This creates a sealed barrier, preventing lateral moisture from penetrating the structure. This step complements the earlier damp-proof layer. If the base layer blocks moisture from rising, this bitumen coating stops water from entering from the sides. Together, they form a closed protection system. Especially important in wet soil conditions where groundwater pressure can fluctuate over time. Bitumen offers strong adhesion and a degree of flexibility. This allows the coating to resist minor ground movement without cracking.
With the foundation and perimeter walls complete, he moves to the next critical phase, floor construction. He begins by installing the floor joists. Each joist is carefully measured and aligned to ensure consistent elevation and proper load distribution. At this stage, even small errors can lead to deflection or uneven flooring over time.
At every point where a floor joist meets the wall, he inserts a thin foam plastic layer in between. This acts as a moisture barrier, preventing dampness from transferring directly into the wood. In many builds, this step is overlooked, yet it's one of the most vulnerable areas, where timber meets moisture-retaining materials like concrete or brick. Wood doesn't fail immediately, but over time, trapped moisture leads to rot, mold, and reduced structural capacity. This layer doesn't carry load, but it breaks the moisture path, an invisible factor that can slowly damage the structure. Especially in humid, rain-prone environments, separating timber from direct moisture contact is essential for durability.
When the floor joists are installed, it's not just about alignment, it's about load distribution. Each joist acts as a bending member. Loads from the floor, people, furniture, and walls are transferred through the OSB panels and distributed across the joists. From there, the load travels to the ends of each joist and down into the foundation system. The principle is straightforward. The more consistent the spacing, the more evenly the load is distributed. If spacing is too wide, the floor will deflect. If alignment is off, loads become uneven, leading to twisting and long-term structural stress. What stands out is his consistent joist layout. This allows the OSB panels to perform efficiently, preventing load concentration at isolated points. Additionally, when joists are properly connected to each other and anchored to the foundation, the entire floor system behaves like a rigid diaphragm, improving vibration control and lateral stability.
Once the joist system is stable, he cuts and installs OSB panels. These panels are not just the floor surface, they become a geometric reference for the wall framing that follows. If the floor is square and dimensionally accurate, wall construction becomes faster and far more precise. A properly built floor system reduces errors for everything built above it.
As he installs the OSB panels, he pays close attention to the panel edges, where performance is defined. The panels are not placed randomly. He cuts them precisely so that every edge lands directly on the load-bearing joists below. This is a basic principle, but often done incorrectly. If panel edges do not sit on joists, the connection weakens, leading to localized deflection or floor noise over time. When edges are properly supported, loads transfer directly from the surface into the joists. No unsupported spans, no hidden weak points. This alignment also improves the connection between adjacent panels. The entire floor begins to act as a continuous surface, enhancing stiffness and reducing movement. He's not just laying a floor, he's establishing a precise structural plane for everything that comes next. A clean cut eliminates problems before they begin.
With the floor system stabilized, he moves to exterior foundation work, insulation, and backfilling preparation. He installs XPS insulation boards directly onto the outside face of the foundation walls. This material resists moisture, does not absorb water, and maintains stable thermal performance in damp soil conditions. Placement is critical. Installing insulation on the exterior protects the entire foundation mass from temperature fluctuation, while keeping the internal structure more stable. He doesn't complete all sides at once. Only about half of the walls are covered, leaving one side open for easier material transport. This is a calculated decision. He prioritizes workflow access instead of sealing everything too early and creating logistical constraints. After that, he begins backfilling around the foundation using large stones. This material improves drainage, reduces soil pressure, and limits moisture buildup against the wall. But manual work quickly proves inefficient. The volume is high, progress is slow, and the physical demand is significant. He stops at the right point and decides to bring in machinery to complete the remaining work. a practical adjustment, keeping construction efficiency under control. With the floor fully secured using a nail gun, he moves into a critical phase, wall framing. Instead of assembling the wall piece by piece in place, he builds the entire wall frame directly on the floor. This is a standard method in timber framing, faster, more accurate, and easier to control. He cuts each piece of lumber to precise dimensions. Studs and plates are laid out with consistent spacing, ensuring proper load transfer from the roof down to the floor system. At this stage, the floor acts as a perfectly flat assembly platform. If the floor is square and level, the wall frame built on top of it will inherit that accuracy. Connections are secured with nails, forming a complete wall panel before it is raised. This approach provides better geometric control compared to assembling components vertically on site. Once completed, the first wall frame is lifted into position as a single unit, efficient, controlled, and structurally aligned.
As the first wall frame is raised, he doesn't rush to the next one. He secures it immediately to the floor joist system. Fasteners are driven at the base of the wall, anchoring it directly into the structure below. This is a primary load transfer point, where vertical forces from the wall move into the floor system. He then installs temporary braces. These supports keep the frame stable and prevent movement during the next stages of construction. The process is repeated for the remaining wall frames. Each one is lifted, aligned, and held perfectly perpendicular to the floor. Maintaining true 90-degree angles between walls is critical. Any deviation here will carry through to the roof and the rest of the structure. Once all 4 frames are in place, he connects them together. Corners are locked in, forming a unified structural system. From this point on, loads are no longer carried by individual walls. They are distributed across the entire frame and into the floor below. A structural system begins to take shape, stable, connected, and ready for the next stage of construction. The joists are placed on top of the walls, connected directly to the top plate. This becomes a key load transfer, where all upper-level loads move into the wall structure below. The principle remains the same, but the demands are higher. The second floor must carry not only live loads, but also additional loads from the roof above. He lays out the joists with consistent spacing. This spacing determines load distribution. The more uniform it is, the more evenly loads are shared, reducing stress on individual members. Orientation also matters. The joists are installed perpendicular to the main load direction, improving bending resistance. When properly connected to both the walls and each other, the system forms a second structural plane, while locking the frame below into greater stability. With the second floor joist system complete, he begins installing the OSB floor panels. Without mechanical assistance, he builds a simple support system using triangular wooden brackets attached to the frame. These act as intermediate supports, allowing him to lift each OSB panel with better control. It's a manual solution, but an effective one, reducing physical strain and minimizing risk while working alone at height. The OSB panels are cut and placed with precision, ensuring all edges land directly on load-bearing joists. He intentionally leaves an opening in the floor. This will serve as the access point between levels, a detail that must be planned early. Once the floor surface is complete, he proceeds with wall framing on the upper level. The process mirrors the lower floor with one key difference: height variation and angled cuts to form the roof slope. This requires a higher level of accuracy in both cutting and assembly, because from this point on, the structure is no longer simple vertical planes, but a more complex spatial form.
As the second floor frame takes shape, one key difference becomes clear. The wall height is lower than the first floor. This is not accidental. It's a deliberate design decision, preparing for the sloped roof system above. Reducing wall height lowers the overall structural weight. It also brings down the center of gravity, improving stability, especially important in open, wind-exposed environments. This adjustment also optimizes interior space. The upper volume will follow the roof slope rather than maintaining a flat ceiling like the level below. From a structural perspective, the second floor is not just another level, it's a transition zone between vertical walls and the roof system. A small change in height with a direct impact on the building's overall form and stability.
With the wall framing stabilized, he moves into the roof system, starting with the rafters. He cuts and prepares rafters approximately 4.5 meters long. These are the primary structural members of the roof, carrying loads from roofing materials, wind, and environmental forces. Each rafter is positioned carefully and secured using a nail gun. This connection point is critical, where roof loads are transferred directly into the wall system below. These joints must be strong, but also precise. He keeps the spacing between rafters consistent. This ensures that roof loads are evenly distributed across the entire structural frame. As the rafters are connected through the ridge and bracing system, the roof begins to function as a unified structural assembly. At this stage, the roof geometry is fully established, and the structural integrity of the building starts to come together.
With the rafter system complete, he moves on to enclosing the roof. OSB panels are installed across the entire rafter surface, forming a continuous base layer. This layer not only supports the roofing material, but also acts as a rigid diaphragm, improving overall roof stability. Next, he applies a waterproof membrane over the OSB. This serves as a critical underlayment, preventing water intrusion if the outer roofing layer fails, and protecting the wood structure from long-term moisture exposure. Finally, he installs asphalt roofing sheets, a common choice for timber frame construction. This material is lightweight, easy to install, and provides effective waterproofing. It also adapts well to sloped surfaces, reducing stress on the underlying structure. In addition, it offers better noise control during rain compared to metal roofing. And when installed properly, it can last for years with minimal maintenance. From structural framing to faux protection, the roof is now not only stable, but ready to withstand the elements.
With the roof complete, he moves on to enclosing the exterior walls. OSB panels are installed across the wall framing. But a practical challenge arises: no scaffolding tall enough, and ordering one would take 2 weeks. He doesn't wait. Instead, he builds his own scaffolding using leftover wood on site. A simple solution, but effective when properly reinforced. More importantly, it keeps the construction process moving forward. What stands out is the material choice, the zip system panels. The green outer layer is an integrated WRB, thermally bonded to the panel during manufacturing. This eliminates the need for a separate weather barrier like house wrap. Once installed, only the seams need to be sealed with specialized tape. The system provides water resistance while still allowing vapor to escape, keeping the internal wood structure dry and stable. It also saves significant time on site, fewer steps, fewer chances for installation errors.
Nails are driven at proper spacing intervals, ensuring consistent holding strength without distorting the panels. As each panel is locked in, the exterior envelope gradually closes. The structure transitions from an open frame to a continuous protective shell. A key factor here is the continuity of the integrated WRB layer. When seams are properly sealed, the entire surface functions as a complete weather barrier. At the same time, he cuts out openings for windows, doors, and ventilation based on the design layout. These cuts must be precise, as openings are the most vulnerable points for water intrusion if handled incorrectly. Predefining these openings streamlines the installation of windows and doors later, while maintaining dimensional accuracy. From a technical perspective, this marks the shift from structure to enclosure. Once the outer shell is complete, the building begins to control air, moisture, and weather exposure.
With the main enclosure in place, he turns to a less visible but critical system: basement drainage. He starts by digging a small pit beneath the floor. This will house the sump pump. It acts as a collection point where groundwater or seepage is directed and contained.
Next, he installs the piping and a float switch mechanism. The principle is simple. As water rises, the float activates the pump. As the level drops, the system shuts off automatically. A basic mechanical system, but reliable for long-term operation without constant monitoring. Protection is key. He wraps the area with geotextile fabric. This layer allows water to pass through while filtering out soil, debris, and fine particles. Without it, the system can clog over time and lose efficiency.
After completing the drainage system, he moves to the next critical step, pouring the basement floor. He starts by laying an insulation foam layer over the crushed stone base. This layer doesn't just retain heat, it also acts as a moisture barrier, limiting vapor rising from the ground. Next, he installs the reinforcement steel above the insulation. The bars are elevated slightly to ensure proper positioning within the concrete slab. He then mixes concrete on site. From the stone base to insulation to reinforced concrete, a layered system built in the correct technical sequence.
He moves on to window and door installation, an essential step in enclosing the structure. He starts with smaller windows for the bathroom and kitchen. Despite having no prior experience, he successfully installs them by following a controlled, step-by-step process. Next come the larger windows, weighing around 100 kilograms. This time, he works with assistance from family members, a necessary and safe decision. The installation follows a clear sequence: temporary support for positioning, to securing with metal brackets, to fastening with screws, to sealing gaps with insulation foam. Each step serves a specific purpose. Skipping any of them can lead to misalignment, air leakage, or poor thermal performance. Once the main door is installed, the house becomes effectively enclosed. Rain and wind are no longer entering the interior space. From this point forward, the project enters a new phase. Work can continue inside, without being dependent on weather conditions. A major milestone, transforming the structure from an open build into a controlled living space.
He defines the stove location and constructs a dedicated foundation for it. This is not a typical floor section, but a point designed to handle both structural load and heat. The base is reinforced to ensure it won't settle or deform under long-term use. He then installs a tile surface on top. This layer serves as thermal insulation and fire protection, preventing heat from transferring directly to the wooden floor beneath. This is essential in any structure using a wood stove. Without proper protection, heat buildup can lead to hidden fire risks or long-term structural damage. The tile layer also helps distribute heat more evenly, reducing localized hotspots and improving safety.
From the exterior, he installs a chimney pipe running straight up through the roof. This vertical design is intentional to maximize natural draft. The principle is simple. The straighter the pipe with fewer bends, the more efficiently hot air rises. This improves stove performance, reducing the risk of smoke flowing back into the living space. The chimney is securely mounted to the exterior wall with proper clearance from combustible materials. From inside to outside, the stove and chimney must function as a single system, not just to vent smoke, but to ensure safety and combustion efficiency.
He hires a professional electrician to run the wiring. This is the right decision, as electrical systems require strict safety standards and are difficult to modify once enclosed. With the wiring in place, he installs insulation within the wall and ceiling cavities. This layer improves thermal performance, reduces energy loss, and enhances sound insulation. Next comes the vapor barrier. This membrane is applied on the interior side to control moisture from indoor air. The principle is straightforward. Prevent warm, moist air from entering the insulation layer where it can condense and reduce effectiveness. Finally, he covers everything with drywall panels. This creates a clean, flat surface ready for interior finishing. What stands out is not just how he builds this house, but why he started. He once had a stable life in the city, comfortable, convenient, with everything within reach. But sometimes having everything doesn't mean feeling complete. He chose to walk away, not out of lack, but in search of something more meaningful. A piece of land, a home built by his own hands, and a life where each day carries real purpose. More importantly, he's not doing this alone. He's building it for the future with his fiancée. Out here, there is no instant convenience, but there is control. No city speed, but a deeper sense of ownership over life. The lesson isn't that everyone should leave the city. It's about understanding what you are truly living for. Sometimes building a house is also a way of rebuilding your life.
Once the wall and ceiling surfaces are fully smooth, he moves to the finishing stage, painting. He starts with a primer coat. This layer improves paint adhesion and equalizes surface absorption across the drywall. Without it, the final paint can appear uneven or patchy. He then applies 2 finishing coats in a coconut tone, a soft white. It's not overly bright, but enough to reflect natural light throughout the space. Beyond aesthetics, paint also acts as a protective layer. It helps resist dust, moisture, and extends the life of the underlying surface. What stands out is the controlled process. Each coat is applied in sequence, allowing proper drying and bonding. From raw structure, the space now begins to feel like a real home.
As the stove area takes shape, he moves into detailed finishing, starting with the wall behind the heater. Stone look panels are installed to protect the wall from heat exposure. Not just decorative, but also reducing direct thermal radiation to the surface behind. Next comes grouting the tile floor around the stove. He carefully cleans the joints before applying grout, a small step that directly affects adhesion. The task itself is quick, around 20 minutes, but cleaning afterward takes significantly more time. If excess grout isn't removed promptly, it can leave residue on the tile surface, affecting both appearance and long-term maintenance. He then focuses on the metal components around the stove. These are coated with heat-resistant paint, rated up to approximately 400 degrees Celsius. This is essential in high-temperature zones. Standard paint would quickly degrade or fail under such conditions. Due to cold weather, he uses a heat gun to speed up the drying process. This ensures proper curing while maintaining construction progress. Small details, but critical for both safety and long-term performance of the stove area.
As he moves into the bathroom, he starts with a critical technical step, creating the shower slope. A shower floor cannot be flat. He forms a gentle slope toward the drain, ensuring water flows properly without pooling. He uses a specialized mortar mix reinforced with mesh. The mesh helps control cracking and maintains surface stability over time. The challenge here isn't just creating slope, but achieving a smooth, consistent gradient across the entire surface. Once the shape is complete, he moves to the most critical step, waterproofing. A waterproof membrane is applied across both the floor and surrounding walls. This acts as the primary barrier, preventing water from penetrating the structure behind. In practice, if this step is done incorrectly, everything built on top becomes vulnerable. Water will always find a way, and the damage often appears much later.
While waiting for the waterproofing to cure, he doesn't pause. Instead, he shifts to another task, building the staircase. He begins by designing and calculating an 11-step staircase. Next, he creates a template. This is critical for ensuring that every step is cut and installed with exact consistency. Even a small variation in one step can disrupt the balance of the entire staircase. If the rise is too high, it becomes difficult to climb. If the run is too shallow, movement feels awkward and unstable. He calculates consistent dimensions to ensure a natural walking rhythm.
Before tiling, he installs an important system in the bathroom, electric underfloor heating. The system consists of heating cables pre-mounted on a mesh mat. He simply rolls it out across the floor and secures it in position before tiling. The working principle is straightforward. Electric current flows through the cables, generating heat and warming the floor surface. The benefits are clear. It keeps the floor warm during cold conditions, helps dry the surface faster after use, and reduces long-term moisture buildup. A small upgrade, but one that significantly improves daily comfort. With the heating system in place, he proceeds to tile installation. He uses wood-look tiles, combining the warmth of wood aesthetics with durability in wet environments. The tiles are installed sequentially from floor to wall, ensuring clean alignment and a continuous finished surface. From hidden technical layers to visible finishes above, the bathroom becomes not just waterproof, but comfortable to use. The work is gradually entering the final stages.
He begins installing the glass enclosure for the shower area. Each panel is carefully aligned and securely fixed to ensure proper water sealing. This is a high moisture zone, so all joints must be sealed thoroughly with specialized materials. Next, he installs the vanity unit and sink. These elements must align perfectly with the plumbing system already in place behind the wall. Accurate leveling is critical to ensure proper drainage and prevent water pooling. He then completes the setup with mirrors and hanging fixtures. Small details, but essential for daily usability. Each component is placed with intention. The bathroom gradually becomes a complete, functional space.
He returns to the staircase, a critical connection between the two levels. He installs the stair treads, carefully aligning each step to ensure a level and solid walking surface. The stair opening is also finished with wood trim, protecting the edges and creating a clean transition. Next, he installs the second floor flooring using engineered wood planks. Beneath, he lays a special adhesive underlayment, providing bonding while also reducing noise. The planks feature an interlocking system. Once connected, they form a stable and uniform floor surface. Outside, he adds a small roof overhang above the main entrance. Designed with a slope and finished to match the main roof, it provides protection from weather and extends durability. In the upstairs bedroom, he builds a wardrobe using OSB panels. These are then painted white, creating a brighter and more organized space. From structure to functionality, the house now begins to operate as a complete living environment. Finally, he completes the kitchen, the central hub of the home. He begins by installing the kitchen cabinets and shelving. Each unit is aligned to the correct height, ensuring a level and consistent countertop. Next comes the countertop installation. He precisely cuts openings for the sink and induction cooktop, a step that requires accuracy, as even small errors can affect the final fit. The cut edges are carefully sealed to prevent moisture from penetrating the material over time. He then installs the appliances, the oven and dishwasher. These must connect properly to the pre-installed electrical and plumbing systems. The key here is integration. All components, from cabinetry to appliances, must function as a unified system, not just for cooking, but for long-term usability and durability. With these final details in place, the house is now complete.
In the final stage, he returns to complete the exterior, the layer that protects the entire structure. The wooden cladding is treated with a stain. Not a surface paint, but a penetrating finish that preserves the natural wood grain. This stain serves two key purposes. First, it protects the wood from rain, sunlight, and UV exposure. Second, it allows the wood to breathe, reducing the risk of warping and cracking over time. Exterior finishing always requires the right material. If done incorrectly, the protection can fail after just a few seasons. He then builds the front deck. The substructure is solidly installed, ensuring proper load distribution and drainage. Deck boards are laid with small gaps between them. These gaps are intentional, allowing water to drain and wood to expand naturally. The deck is more than just an entrance. It acts as a transition space between indoors and outdoors. After more than 9 months of construction, this project is finally complete. This is not just a house. It is the result of a long journey built on effort and persistence. Every foundation, every wall was shaped by time, hard work, and difficult decisions. But more importantly, this is not the end. It is the beginning of a new life, a life chosen with intention and built by hand. This journey shows something deeper. Building a home is not just about materials. It's about persistence, sacrifice, and a dream finally brought to life. If you're thinking about starting your own journey, begin with small steps. And if you found this video valuable, leave a comment, hit like, share, and subscribe to Quantum X. Thank you for watching until the end. See you in the next journey.